I've had a few questions about finding electron configurations for elements. So this is going to be a short video tutorial. My assumption here is that you've read through the content for the atomic theory section and you've got a basic understanding of electron configuration, or the basic understanding of the structure of the quantum model before going through this, like the idea of orbitals and subshells and that sort of thing. Before we get to electron configuration, I just want to remind you of a few basic concepts that you need to know. Okay, first of all is the idea that the main energy levels are broken up into subshells, and depending on which energy level we're at, there's a different number of subshells. So for example, for n equals 1, there's an s subshell. For n equals 2, there's an s, a p subshell. N equals 3, there's an S, a P, and a D. Now up here, I have a capacity list here. Each subshell type has a different capacity. An S-type subshell has a capacity of 2, P has a capacity of 6 electrons, D 10, and F 14. So at the main energy level 1, there's only one subshell type, and so the S subshell has 2 electrons. At the second energy level, there are 2 energy levels, starting in 3, 2. At the second energy level, there are 2 subshells, an S, a P, which holds 6, for a total of 8 electrons, which remember from the Bohr model. And then the next energy level, S, P, D, 2 plus 6 plus 10 equals 18 electrons, right? The 2n squared. So as you can see, at every energy level, the lowest energy subshell is the S. It fills first, and then we keep adding subshells as we move up in energy levels. The second principle is the off-bow principle. So you might have heard that before. That is the idea that electrons always fill from lowest energy to highest energy. This is an off-bow diagram right here, and it is a diagram which shows you the order at which the subshells fill. So I'm going to do a little start up here. Start. There we go. Start, and I follow the arrows here, and when I hit the left-hand side, I go to the next arrow. So the order of subshells, 1s fills first, then I go here, then 2s second, 1s, and then next up, I hit 2s, and now I'm on my third arrow here, 2p, then 3s, and then 3p, then 4s, and you keep following the arrow. So once again, we start at the top, we go from right to left, and then every time we hit one of these subshells, that's the order that they filled. So 1s first, 2s, 2p, 3s, 3p, 4s, 3d, 4p, and so on and so forth. I think it's most helpful to use the periodic table to figure out electron configuration rather than trying to memorize this diagram. So let's go to that now. This is our periodic table, and it's a periodic table that represents the quantum model in the terms of the colors here. So I got this periodic table from a website, ptable.com. It's a really useful website for chemistry. It has very different online versions of the periodic table, which visualize it in slightly different ways. I would highly recommend it. So that's where I captured this image from. So let's recall what we had in that last screen. The S subshells have 2 electrons. P subshells have 6. D subshells have 10. And F subshells have 14. If we look at the periodic table, it can be divided up into 4 blocks. The groups 1 and 2 is referred to the S block. Okay, 2 groups, and we're called S block, and remember the S subshell has a capacity of 2. Groups 13 to 18 is referred to as the P block. 6 elements across, or 6 groups. The P subshell has 6. The transition metals through here, those are the D block. And then those 2 rows which are pulled out of the periodic table, that is the F block there. 14 elements across. The D block, 10 elements across. So we can see the structure of the quantum atom in the organization of the periodic table. So let me now do an example of an electron configuration. I'm going to make the table a bit smaller, and we will try to figure out the electron configuration. I'll go through the process there. So let's find the electron configuration for an element like carbon. Oops, there we go, carbon. So my first step for finding electron configuration is I find the atomic number, because for a neutral atom, the atomic number equals the number of electrons. So carbon, 6 electrons. To do the electron configuration, I start building up. To build up, I just work my way from element 1, and I start going across, and then when I've hit the right-hand side, I go down. So I start off with hydrogen. Elements in the first period are at the first energy level. So I'm going to write 1 there. That's the first energy level. And the first 2 elements are in the S block, which is the first subshell that fills. Then I'm going to write an exponent here that tells me how many electrons are in the subshell. So now I've placed 2 electrons in the S subshell of the first energy level. So I've reached helium here. No more elements. Move down. Next element, lithium and beryllium. 2 more elements in the S block, but this time I'm on the second period. So 2s2. The exponents tell me how many electrons I have in total. So I've now filled 4 electrons. There's carbon. I need 2 more electrons. If I follow the periodic table, lithium, beryllium, 3 and 4. Next up, boron, and then carbon. So 2 more electrons. And now I'm in the P block. I'm still in the same period, so still 2. So the P block, and I've placed 2 elements in there to get to carbon. So there's, if I add up, or if I look at the total number of electrons, 2 plus 2 plus 2, 6. There's my configuration for carbon. Now that we've written it out, let's notice a few other things. Carbon is the second element in the P block. So that tells me that the highest energy subshell is going to be P2. Note, carbon, 2 elements in, 2 electrons in the P block. So the location of the element tells you where to stop. Let's do one more example here. Let's do sodium. Let's do magnesium. So magnesium. Magnesium has 12 electrons. And magnesium is the second element in the third period in the S block. So that tells me my highest energy subshell is going to be 3s2. So I start building up. Elements 1 and 2, 1s2. Elements 3 and 4, second period, second energy level. S block, 2 electrons. Next 6 elements, second period, but I'm in the P block, so those 6 electrons go in the P subshell. Now I'm in the third period, so the third energy level. Magnesium is the second element in the S block. Add up the electrons. 2 plus 2 plus 6 is 10, plus 2 is 12. So I've got the correct total number there as well. You'll see this written slightly different some places. Sometimes you'll see the main energy level repeated. I like to just write it once and group them together after that. Let's try one more example that involves the D block, which is a bit more complex. Let's do manganese. So there it is, element 25, 25 electrons. So one thing we've seen so far is that the period that we're in matches up with the main energy level. But the D block and F block work slightly different. One thing that happens with the electron filling is that an S subshell at a higher energy level fills before we get to a D subshell. So let's just recall here before we do this. The first energy level, there's an S subshell for a total of 2 electrons. The second energy level, we have an S and a P for a total of 8, 2 plus 6. At the third energy level, we have S, P, and D, 2 plus 6 plus 8. And the fourth energy level, S, P, D, F, 2 plus 6 plus 10 plus 14. Made a mistake there. Not 8, 10. Okay. So manganese, just like the other ones, let's see where we are. Manganese is 1, 2, 3, 4, 5 elements in the D block. So it's going to end in D5. That tells me where its valence subshell is. So let's start building up. 1s2, 2s2, P6. So there's 10 electrons. That gets me to neon. And then now I'm at sodium, element 11, sodium and magnesium, 3s2. I'm over next up, aluminum, and moving across the P block, the next 6 electrons fill the 3p6. So let's go back to these here and say, what have we filled so far? Okay, we filled the 1s, we filled the 2s, we filled the 2p subshells, we filled the 3s, and we filled the 3p. So this is where things get funny. The third energy level still has a D block to be, or the D subshell to be filled, but the S block at a higher energy level always fills before we fill that D block. So if I'm following my electrons here, 3s2p6, that gets me to argon. So let's look at the periodic table. After argon, the next element is potassium. S block. So the next S subshell available is the 4s, fourth period, S1, S2. Okay, so now we filled the 4s. And what's next? Now we're in the D block. So what D block hasn't been filled yet? The 3D. 3D, 10 electrons, 10 elements across. However, we're stopping at manganese. So we're going to end at 3D5. So typically this is simplified a bit where we group all of the subshells with their main energy level. So I'll put the 3D with the other 3s and then write 4s squared, or not 4s squared, 4s2. So this first one here, I was kind of figuring out by just following the order that they fill. And then this is simplified. It really doesn't matter one way or the other, but this is the second version here is the convention. So just things to remember. For the S and the P block, the period that you're in matches with the main energy level. Third period, 3s, 3p. Fifth period, 5s, 5p. For the D block, it's always one behind or one lower. So fourth period, the 3D subshell. Sixth period would be these elements here, the 5D subshell. You're always one behind. Okay, so hopefully that is helpful for a start there.